Good morning, my good students. This is Dr. Morgan over at Clovis East High School again. Today's lesson 8.2 is a review, pretty much. We have covered zero and negative exponents before, but we need to review them again as we get into looking at exponential functions. So let's get started. First, let me show you a slide that starts with understanding how exponents work, how it's continuing to multiply by the same number. But then I want to work it backwards to give you an idea where the concept of a zero exponent and a negative exponent comes from. As we start here, you notice right away that 5 to the 1 is simply 5. It's one factor of 5, 5 times 5. And then we know that 5 squared means 5 times 5, which is 25, and 5 cubed is 5 times 5 times 5 3 times. That's what the exponent means. You take the base of 5 and multiply it by itself 3 times, 125. So 5 to the 4th is 4 times 4 fives. Not 4 times 5 is not 20. It's 5 times 5 times 5 times 5, or 625. And 5 to the 5 is 5 factors of 5, or 3,125. Now we should understand that. We've known that for a long time. But let's consider what the zero exponent and the negative exponents mean. Let's start at the top and work backwards. Notice that if I start here, if I take 3,125 and divide by 5, in other words, what I'm doing is taking away one factor of 5, I end up with 625. If I take 625 and divide it by 5, I take away one factor, and now I'm left with 3 factors. I'm back down to 125. If I again divide by 5, I'm to 25. 25 divided by 5 is 5. And so we've worked it down backwards. What happens if we continue the pattern? What is 5 divided by 5? It is 1. In other words, 5 to the 0 power is 1. And one thing we're going to learn in a moment is any number to the 0 power is 1. What happens when I go now, keep going, I've gone 5, 4, 3, 2, 1, 0 to minus 1. Well, let's continue our pattern. Divide by 5. What do I get? 1 over 5. See, this is the reciprocal of 5 one time, or I'm dividing by 5 one time. Up above, I was multiplying by 5 one time, or 2 times, or 3 times. In the negative exponents, I'm dividing by 5 that many times. So notice when I divide by 5 again to get 5 to the minus 2, I get 1 over 5 times 1 over 5, or 1 over 5 squared, or 1 over 25. You might notice there's a correlation here. If I were to draw this, notice the correlation here between the 25 and the 25 here. The 5 squared is 25. The 5 to the minus 2 is 1 over 25. Likewise, 5 to the minus 1 is, there's a 5 and a 5. And we could continue on. You can see if I wanted to say what is 5 to the minus 3, I can already tell you it's going to be 1 over 125. Because it's going to be 1 over 5 to the 3rd, or 1 over 125th. All right? So here's our box on what's good to know. Zero and negative exponents. Zero as an exponent. For every non-zero number a to the 0 equals 1. You know, if I say what's 5 to the 0, you say 1. If I say what's 125 to 0, it's 1. If I say what is negative 38 to the 0, it's 1. If I say what's x to the 0, it's 1. The only time it's not 1 is if it's 0. And that's why we say for every non-zero number a to the 0 is 1. Negative exponents. For every non-zero number a and integer n, a to the minus n actually means 1 divided by a n times. All right. See, so the negative exponent never means negative number. It means it's the opposite of a positive exponent. A positive exponent, we are repeated multiplication. A negative exponent means repeated division. It's 1 divided by a that many times. So if you have a negative exponent, what you do is you take the reciprocal of the base. Like in the case above, I take a and make it 1 over a, and then I change the exponent to positive. So a to the minus n becomes 1 over a to the positive n. A simplified expression should never have negative exponents. For example, if I have 3 to the minus 2, I take 1 over 3 and then make the 2 positive. So it's 1 over 3 squared, which becomes 1 over 9. Likewise, what if the negative exponent's already in the denominator? Well, again, I take 1/2 and take the reciprocal and change it into 2 over 1, and I change the reciprocal of the minus 3 to 3. So notice sometimes it's easy when you're solving problems to think if I have a negative exponent in the numerator, I move it down to the denominator and make it positive. Or if it's already in the denominator, I move it up to the numerator and then make it positive. So this becomes 8 over 1. Take a look at this example here, more complicated. I have 3 to the minus 2 times 4 to the 0, 5 squared, divided by 2 to the minus third, 7 squared. Well, just start working through it. First of all, if you notice the 3 to the minus 2, I'm immediately going to take the reciprocal, so I'm going to move that down so it becomes, here in the blue in the bottom, 3 squared in the denominator. Likewise, the 2 to the minus third in the denominator at the beginning, the 2 moves up above the blue on top here and becomes positive 3. That's our first step. Now I notice here I have a 4 to the 0. So my next step is to simplify. 2 to the third power, 2 times 2 times 2 is 8. 4 to the 0 power, any number to the 0 power is 1. 5 squared is 25. 3 squared is 9. 7 squared is 49. Then we multiply them all together and we get our answer. So let's look at 1a, 1b, and 1c. Notice they all have an exponent of 0. What do we learn about these? Every non-zero number, a to the 0 is always 1. So what do you think 4 to the 0 equals? 1. What does negative 5 to the 0 equal? 1. What does x divided by 101 to the 0 power equal? 1. And don't make the mistake of thinking it's 0. Any number to the 0 power equals 1. Think back to that example at the beginning where we were doing all the multiples of 5. We worked our way down, 1, 25, 25, 5, and we divided 5 by 5, we got 1. No matter what factor you'd be using, you'd always end up with 1. So now let's consider some negative exponents. Look at my examples below again. 3 to the minus 2, I take the 3 and find the reciprocal, 1 over 3, and I make the 2 positive. Okay, and so we see that, for example, in 1D. Take the example 9 to the negative 1, make it 1 over 9 to the positive 1, and so that just simply becomes 1 over 9. In 1E, I take the reciprocal of minus 3 and make it 1 over minus 3, and then I change this to a positive 2, so 1 over minus 3 squared. Notice I can write it as either 1 over minus 3 squared, or I can write 1 over minus 3 quantity squared. Either way it's going to be the same, because obviously 1 squared is going to stay that way. So I end up with 1 over minus 3 squared, or 1/9. Okay. Now in F, look down at my example at the bottom. Notice if my negative exponent is in the numerator, then again the reciprocal will take the 2 and put it on top in the numerator. The reciprocal of 1/2 is 2 over 1, and now I change minus 3 to 3. So in this case here I have b, and I'm going to do the reciprocal. Now be careful here. We're only taking a reciprocal here of the, I need to split this up so it's 2 times 1 over b to the minus third. When I go take care of the negative exponent, I'm not going to take the reciprocal of the 2. That doesn't have the exponent. Only the b does. So now I take 1 over b and do the reciprocal. The reciprocal of 1 over b is b, and then make the exponent positive. So I end up with 2 times b to the third over 1, or simply 2b to the third power. Now as we move to problems 2, you'll notice that we're simplifying expressions. In this case, what we want to do is kind of like combining like terms, but what we're going to do is put our like terms together so we can put all the exponents together. So when I look at this problem here, what I really have is 5 times a to the third times b to the minus 2 quantity times the quantity 2 times a squared times b. Well, let's put our coefficients together, 2 and 5. Let's put our a's together. Let's put our b's together and write it this way. So I have a 5 times a 2, I have an a third times an a squared, and I have a b to the minus 2 times b. Now notice here in the blue, I put down that b is also b to the 1 power. Remember, lots of times when we have just to one factor of a number, we just leave it off there. We know b is b, and we don't always put the 1, but I want to put it here because we need to remember our rules when we come to apply these. We're going to have to keep the base and add the exponents. So here I have 10. When I multiply exponents, I keep the base a and I add the exponents 3 plus 2. And my b here, I'm going to keep the base b and then I add a minus 2 plus 1. Notice why I put the 1 here. If you don't, sometimes students go, oh, there's no exponent, I'll put it 0. No, there is one. It's 1. Now we just simplify that. We have 10 a to the 5 b to the minus 1. One note we made above, though, when we simplify exponents, we never want to leave a negative exponent. So in this case, I need to change b to the minus 1 to 1 over b to the positive 1. In other words, it comes down, and my final answer is 10 a to the 5th divided by b. So let's do the same thing on 2b. All right. Here it is split out, minus 5 times x squared times y times the quantity negative 2 times x cubed times y squared. Now let's combine, put the coefficients together, the x's together, and the y's together. So I have 5 times minus 2. I have x squared times x third, and I have y to the 1. See my little 1 again there. The y is actually y to the 1 times y squared. So in this case, I have 10. Negative times a negative is positive 10. X to the 2 plus 3. Y to the 1 plus 3. I have 10 x to the 5 b3. Didn't have any exponents, so that one made it a little bit easier. So now let's simplify some ones that are fractions. My first step usually in all these cases is to try to get rid of the negative exponents first. In other words, make the negative exponents positive. If you see in the example below, I give, notice I took the 3 to the minus 2 and it became, that moved down. I'm always thinking kind of like moving down here. This negative is going to mean it's going to come down. All right. And so you see it comes down here and becomes 3 squared on the bottom. The negative 3 here is going to come up. And so it becomes 2 to the positive 3. All right, does that make sense? So up here, as I'm looking here, I have a 3 to the minus 2 that's going to come down, and I have a p to the minus 2 that's going to go up. All right. So when I start this problem, here's my problem, and so I split it out this way, and I noticed that I just made it all, split out to recognize I actually have 4 factors here. The last factor is a 1 over that. So 3 to the minus 2 becomes 3 squared. P to the 1 over p to the 2, the p goes up. And so I end up here with p squared t cubed over 9. Now one thing I forgot to mention here, what happened here with the r0? Any number to the r0 becomes 1. So that's 1 times t cubed p squared over 3 squared. One other thing I did here, just convention. Mathematicians lots of times want to write their variables in alphabetical order if they can. So I simply changed the order of the p and the t, but it didn't matter. Let's look at the next problem. The next problem, notice that the entire fraction is to the minus 2. Now we learned that when we have a negative exponent, we take the reciprocal of the base. Well, so what we're going to do first is take the reciprocal of this whole fraction and then change the exponent to positive. See how that worked? 6n over m divided by 3m, we took the reciprocal and then we changed it to a positive 2. Now we square those. Everything is squared. 3 squared, n squared, 6 squared, n squared, m squared. So we end up with, by the way, the n squared divided by n squared is going to cancel out. And so in this case, we have 9 divided by 36 m squared. Or 9 goes into 36 4 times, so I have 1 over 4. As we look at 3m squared n quantity to the cube, that means I'm going to take what's inside the parentheses and multiply it by itself 3 times. That's one way of looking at it. Now if I collect all of my coefficients, my m's and n's together, you see I have 3 times 3 times 3. I have m squared, m squared, m squared. I have n, n, n. So when I put these together, I have 27. 3 times 3 is 9 times 3 is 27. M to the 3 plus 3 plus 3 and n to the 1 plus 1 plus 1. So my final answer is 27 m to the 6 n to the 3. And that's our answer there. Now some people would do that in a shortcut way where they'll kind of like distribute the exponent. They'll take 3 to the n and they get n to the third. They'll take the 3 to the m squared, and when you take the power of a power, you multiply the exponents, so you get m to the 6, and then here 3 to the third power. 3 times 3 times 3 is 27. So that is a shortcut way if you understand how that process works. So let's go to 2f. In 2f, if I split this up, the only thing I really need to do is I have to take care of this y squared, okay, the negative exponent. Well, we learned that the negative exponent means it's going to come down. 1 over y and then positive squared. And now we put it back together again. 3x squared, 3x to the 4th over y squared. And we're done with the problem. In problem 3, we're going to use our understanding of exponents to simplify scientific notation expressions. In this case, what we want to do is let's separate the coefficient, the factor there, from the exponent and put them together. So you notice in my first one, I'm going to put the 18 over the 9 together and then times the 10 to the 5 divided by 10 to the 3. In this case, 18 divided by 9 is 2. And then we have to remember our rule. When we are dividing exponents, we keep the base and subtract the exponents. So this becomes 10 to the 5 minus 3, or 2 times 10 squared. And that's our answer, leaving it in scientific notation. 3b, we'll do a similar thing. Separate the 9 divided by 3, that's my initial factor. 10 over 8, 10 to the 8th power divided by 10 to the 5th power. So we end up with 3 times 10 to the 8 minus 5, or 3 times 10 to the 3rd. So those are pretty simple problems. In our next two problems, we're going to make it a little bit harder. We have to do some multiplication on the numerator before we can divide by the denominator. Now notice it's the quantity 6 times 10 cubed quantity squared means that what's inside is multiplied by itself 2 times, like that. So now our combined factors, I'll have 6 times 6, 36. 10 to the 3rd power times 10 to the 3rd will be 10 to the 3 plus 3, or 10 to the 6. So we've simplified the numerator. Now we're going to do like we did in 3a. We'll break out the factors this way. So we have 36 divided by 2 and 10 to the 6 divided by 10 squared. 36 divided by 2 is 18. 10 to the 6 over 10 squared is 10 to the 6 minus 2, or 10 to the 4th. Now, you might be tempted at this point to say, okay, I'm done. But remember, in scientific notation, this particular number here has to be less than 10 and greater than 1. So what we're going to have to do here is we're going to have to change 18 to 1.8 times 10 to the 1. Now that factor 1.8 is what we want it to be, but we have an extra 10. So 10 to the 1 times 10 to the 4, 1 plus 4 is 10 to the 5. And that's our final answer in correct scientific notation. 3D, again, we have the top factor is to the third power. So we're going to take that, what's inside the parentheses, times itself 3 times. So now I'm going to have 4 times 4 times 4, and 10 to the 5 times 10 to the 5 times 10 to the 5, or 4 times 4 is 64, 10 to the 5, 5 plus 5 plus 5 is 15. And now we'll simply divide them. 64 divided by 8, and 10 to the 15 divided by 10 to the 4th. So I get 8 times 10 to the 15 minus 4. So my answer is 8 times 10 to the 11th. Notice the number 8 is between 1 and 10, so that's acceptable. You'll notice in our next set of problems that we made an error in numbering. While we were putting this together for this special class, we had numbered the other ones 1, 2, and 3. These should have been 4, 5, and 6, but instead they ended up being 16, 17, and 18. But you'll get over that. You can just think you did more problems than you actually did. Now what we want to do when we have a problem like this, it says to evaluate 3s cubed t to the minus 2 for s equal 2 and t to the minus 3. I find it helpful to simplify the expression first before I substitute in the values or evaluate it. So when I have this expression here and simplify it, notice I have my t to the minus 2 is 1 over t squared, or this is a simplified version, is 3s cubed divided by t squared. Now let's put in our numbers. So I put in the value here, 3 times 2 cubed over minus 3 squared. So 2 cubed, 2 times 2 times 2 is 8. Notice on the bottom, negative 3 squared, a negative times a negative is positive. So I end up with 3 times 8 over 9. 3 goes into 9 3 times, so I can do this simplification. And I end up with simply 8 divided by 3, 8 thirds, or 2 and 2/3 if you wanted to make it into a mixed number. Now 17 is similar to 16. Notice that first, to simplify the expression, I have a w to the minus 1 in the denominator. So I want to move that up. In other words, the w to the minus 1, the reciprocal of 1 over w is w, and I change it to 1. So now when I simplify this, I simply end up with w over n is what this expression really is. Now we can put the values in. W is 5 and n is minus 2, so I have 5 divided by minus 2, or I would bring the negative in front and say minus 5 over 2. So in our last problem, I look at it and I realize I'm going to have to simplify it. I've got 2 negative exponents, 2 to the minus 4 and s to the minus 2. So I'm going to need to simplify those and move them down into the denominator. So 1 over 2 to the minus 4 becomes the reciprocal 1 over 2 to the positive 4. And 2 to the minus 2 becomes, s to the minus 2 becomes 1 over s to the positive 2. Put them back together and we have r cubed over 2 to the 4th, 2 times 2 times 2 times 2 is 16, s cubed. Now we can put in the values for our variables and evaluate this expression. So I put in minus 3 for r and 5 for s. Now on the top I have minus 3 times minus 3 times minus 3. Notice that first of all the minus times the minus will be positive, but then the positive times the minus will be negative. Whenever you're dealing with negative factors and exponents, if the exponent is even, like squared 2, 4, 6, the negatives will become positive. However, if the negatives are odd, like 3, 5, 7, in this case 3, there's one extra negative, so the whole expression will be negative. So this will be negative 27 over 16 times 25. So we multiply all that out and we get negative 27 over 400, and that's as far as we can go. All right, I hope this lesson is helpful. You guys be safe out there.